One of the things that happened early on in my career at Dartmouth, when I was becoming involved in the immune system and the immune response, I started collaborating with an endocrinologist. His name was Alan Monk. He was about 10 years my senior. And it turns out that I was in the right place at the right time because Alan could impart to me all of the classic aspects of what a hormone was and what a hormonal system was. And I started collaborating with him way before I got involved in interleukins and things beyond that. And we started looking at glucocorticoid receptors on lymphocytes. And glucocorticoids are a hormone that is made by the adrenal gland under the influence of another hormone coming from the pituitary gland, which is up in the brain. Pituitary gland makes a hormone that activates the adrenal gland to make glucocorticoids. And it turns out that everyone knew from the 50s, 1950s and on that for some reason or another, the glucocorticoid hormones were immunosuppressive, but nobody knew why. And then what happened is that in 1960, a young investigator at the University of Pennsylvania in Philadelphia discovered that if he took certain substances that were bind onto blood cells, that he could activate lymphocytes to start proliferating. And this substance was an extract of a kidney bean. It was called phytohemagglutinin. It turns out that once he found that, the very first experiment he did was to put glucocorticoids into his culture. And lo and behold, what happened was that the glucocorticoids inhibited the proliferation activated by the phytohemagglutinin. So we knew all that in the late 70s and early 80s when we were beginning to understand that there is this substance that we called T cell growth factor. And one of the things we wanted to know right away was, well, we knew that the glucocorticoids inhibited the proliferation of the cells in response to the phytohemagglutinin. So the question was it due to the fact that it prevented the production of the T cell growth factor, or it prevented the activity of the T cell growth factor? And we found just very striking results, black and white, that it completely cut off TCGF production. And if that wasn't enough, it also inhibited the activity of TCGF by about 20 to 30%. So that was another eureka moment, because what that meant was that there was a connection between the immune system and the classic endocrine system. And so what that did was that put the immune system into the context of another system within the body that is being regulated by other aspects of the body, and that it all fits together in a very complicated mix of molecules and cells that allow us to be what we are today.